A hook ammeter is a tool widely used by electricians to measure the current flowing through a cable without cutting or peeling it. Using a no-hook ammeter, I made a performance monitor for a solar energy grid tie system. The idea is to place the hook around one of the power cables coming down from the microinverters. Then the hook is closed and the ammeter will read the current going down the wire. If the supply voltage is, say, 220 volts, you can then multiply the current reading by the known line voltage, 220. The result would be the power in watts generated by the system. If the ammeter reads 2 amps, we are then producing 2 by 220 equal to 440 watts. But we can go beyond that. If we take apart the hook ammeter, we can install the hook with its coil close to the cable coming down from the inverters and extend a thin length of wire to the ammeter circuit. For calibrating the reading on the ammeter as watts, you can add a small preset control to make the instrument show the watts being produced. In order to improve the precision of our arrangement, we must observe a small green LED light on the bidirectional meter which flashes every so often. By counting the seconds elapsed between blinks, you will have all the necessary data. 1, 2, 1, 2, 1, 2. If, for example, we count 2 seconds between blinks, we must divide 3600, the number of seconds in an hour, by the seconds elapsed between blinks. In our example, 2 seconds, and the result will be 1800. This tells us that we are producing or buying 1800 watts per hour. In order to tell if the power is being produced or bought from the company, we must check the arrows on the upper left side of the meter. If the arrow points left, we are producing. If the arrow points right, we will be buying electricity from the power company. During the following test, the arrow of the light meter should point left. Now we must disconnect all household appliances. Then we must count the seconds between LED blinks, perform the division, and then slowly turn the preset control until one of the ammeter scales reads the amount we figured in the calculations. In the previous example, the power was 1800 watts. We must turn the control until we see that on one of the scales of the meter, the needle points at either 1.8, 18, or 180. Of course, the scale should be linear, not logarithmic, so that all other readings are close to real wattage. I hope this video has been useful to you. Thanks for watching and please subscribe to my channel.